Happy morning to everyone. In our last video, we discussed unit 2 quantum mechanical model of the atom. In that video, we discussed the wave character of electron proved by Davison-Germer experiment. So, in that experiment can be explained by based on electron diffraction experiment. Now, in this video, we will see about Heisenberg uncertainty principle. Heisenberg uncertainty principle states it is impossible to measure simultaneously both the position and velocity or the momentum of a microscopic particle with absolute accuracy or certainty. இங்கே uncertainty என்னக்கா நிலையில்லா. ஸோ இதை தமிழில் சொல்லும்போது ஹெய்சன்பர்க்கின் நிலையில்லா கொள்கை. இங்கே என்ன சொல்ல வர்றாருனாக்கா ஒரு மைக்ரோஸ்கோபிக் பார்ட்டிகல்ஸ் லைக் ஏ புரோட்டான், எலக்ட்ரான், நியூட்ரான், அதர்வைஸ் ஆட்டம்ஸ் ஆர் மாலிகூல்ஸ் அதனுடைய பொசிஷனையும் வெலாசிட்டியும் நம்மளால சைமல்டேனியஸாக கால்குலேட் பண்ண முடியாது. You can calculate either position or velocity of the microscopic particle. So this principle is called as Heisenberg uncertainty principle. தமிழில் சொல்லணும்னாக்கா ஹெய்சன்பர்க்கின் நிலையில்லா கொள்கை. So this is applicable only for microscopic particle. Now what about the mathematical expression for Heisenberg uncertainty principle? Here the Heisenberg uncertainty principle mathematically expressed by del x into del p is greater than or equal to h divided by 4 pi. Here h divided by 4 pi you consider as a h bar divided by 2 is there. Here del x is nothing but uncertainty in position, del p is nothing but uncertainty in momentum. The more accurate you know the position, that means del x is smaller. Otherwise, the less accuracy we know the momentum at the larger del p and vice versa. இங்கே del என்றது எதை ரெஃபர் பண்ணுறதாக்கா எஸ் நெட் சேஞ்ச் a net change of position, the net change of momentum. So the product of uncertainty position and uncertainty momentum is greater than or equal to h divided by 4 pi. So the h divided by 4 pi எதுக்கு ஈக்குவலாக இருக்கும் h bar divided by 2. So here always greater or equal to h divided by 4 pi, never be a less than 2 h divided by 4 pi. This is called as Heisenberg uncertainty principle. அப்போ Heisenberg uncertainty principle என்ன சொல்றாங்க? If I know the position, we can calculate the momentum of microscopic particle. Otherwise, if I know the momentum of the microscopic particle, we can calculate the position of microscopic particle. We know that momentum which is equal to the product of mass and velocity. So if I know the position, we can calculate velocity. Otherwise, if I know the velocity, we can calculate position also. So the equation will be interchange. So this is called as Heisenberg uncertainty principle. Once again, I remember you what is the Heisenberg uncertainty principle. It is impossible to measure simultaneously both position or and velocity or momentum of the microscopic particle with an accuracy or certainty. This principle is called as a Heisenberg uncertainty principle. What about the limitation of Heisenberg uncertainty principle? The uncertainty principle has negligible effect for macroscopic objects and becomes significant only microscopic particles such as electron or proton. So இங்க என்ன சொல்ல ஆல்ரெடி சொன்னதுதான். So this effect can be applied only for the microscopic particle. Does not apply for macroscopic particles. So that's all about the Heisenberg uncertainty principle. What is the Heisenberg uncertainty principle? It is impossible to measure simultaneously both the position and velocity or momentum of the microscopic particle with an accuracy or certainty. So இங்க uncertainty என்ன சொல்ல போறோம் நிலையில்லா. So இந்த பிரின்சிபல் சொல்லலாம் Heisenberg நிலையில்லா கொள்கை. So that's all about the Heisenberg uncertainty principle.
Uncertainty principle. In 1927, Werner Heisenberg proposed uncertainty principle. Statement: it is impossible to determine simultaneously and accurately the position and momentum, velocity of subatomic particles like electron in an atom. Mathematical representation: the product of uncertainty in position and uncertainty in momentum is greater than or equal to h by 2 pi. Delta x into delta p is greater than or equal to h by 2 pi. Equation 1, where delta x, uncertainty in position, delta p, uncertainty in momentum. but momentum p is equal to mv, where m is mass of electron, v is velocity of electron. Therefore, delta p is equal to m into delta v. Equation 2. Mass of electron is constant. Substitute equation 2 in equation 1. Delta x into m into delta v is greater than or equal to h by 2 pi, where delta v, uncertainty in velocity. Case 1. If delta x is equal to 0 and delta v is equal to infinity. This indicates if the position of electron is determined accurately and inaccuracy in the velocity is infinity. Case 2. If delta x is equal to infinity and delta v is equal to 0. This indicates if the velocity of electron is known precisely, delta v is equal to 0, then the position of electron will be uncertain. Delta x is equal to infinity. Physical concept of uncertainty principle. The position of an electron can be determined with light of high energy, wavelength less than electron, that is photon. If photon collides with the electron, it instantly changes the direction and velocity of electron. Limitation. This concept is insignificant for large objects.
Heisenberg's uncertainty principle. We will take an example to understand uncertainty principle. Let there be a blindfolded person in a room searching for a ball, whose velocity he has been told, but not the position. He will come to know the position of the ball when the ball collides with him. But at this point of time, the velocity of the ball would have changed due to the collision. This is precisely what Heisenberg stated, that exact velocity and exact position cannot be determined simultaneously.